behalf of Team Binary Search, I'm going to be your presenter today. My name is Prem Rajendran. So the idea that we have in mind is actually sustainable recycling with artificial intelligence. So since the theme of the competition was sustainable engineering, we thought along the lines of recycling, which is obviously a global problem that the world faces on a general basis. All right. And the idea or the thought that we had was to use image detection systems to increase the efficiency of recycling. Now, AI-enabled waste bins, how would they work? Well, let's go ahead and see. So the proposal that we have is an AI-enabled system inside normal waste bins. So obviously the shape and the general, and the general way that these waste bins are perceived are going to be the same way as they are right now, but they're going to be AI enabled, right, to automate the sorting process inside bins. So instead of having multiple bins for, well, glass materials, metal materials like aluminium and paper and other general waste, we were proposing one singular bin that's able to sort all of this as you just dump it in. So then no human labor is required to pre-sort any of the waste before it's sent to recycling. And also, in the case where there is limited space in an area, instead of having multiple bins for each and every single waste, it allows us to have one single bin that sort of acts as a one-stop for all. And this basically helps us save time, money, and even space. So why is this issue prevalent, and why would something like this need to be addressed? Well, let's talk about the harms of this issue. Now, sometimes the normal regular recycling bins, they're not always followed. Sometimes we see in our day-to-day life that a lot of people, they just throw waste wherever they can, and they don't really care for what is labeled on that bin. So with the customers generally don't really have the sense, not all of them obviously, but some of them don't really have the sense to want to put waste in where it's supposed to be. And this has a negative impact on the workers who are working for these recycling companies. These people have to sort out or pre-sort all of this waste before it goes to recycling, and that increases more labor on them. And also, it makes it difficult for them to find out what's actually recyclable and what's just been thrown into the bin, or what needs to just go to what can be decomposable into the environment. So it also could contaminate other sought after items. So for example, paper, if it's mixed with something like a liquid, it basically becomes damp, and then it becomes unusable, and it's not recyclable anymore. Items like paper and cardboard, as a matter of fact. Furthermore, plastic shopping bags pose the biggest problem for most recycling facilities, as the bags could wrap around their machinery and cost over $10,000 to replace. And that's a heavy cost to incur. Moreover, the once profitable business for cities and private employers is becoming a more profitless enterprise, and the future is never looking great, honestly. And waste management has been reporting a 16 million loss in this quarter of the first year. This is a company based in the US, in Houston. Daniel, if you could go to the previous slide. Sorry, I wasn't done with that. Yeah. So yeah, the Houston-based company has pointed to different closures for the temporary solution, and because of all these losses, one in 10 of its biggest recycling facilities has shut down as a result of the losses. So as we can see, the impact of this issue is not only just social or economic, it's actually a combination of both. There are various challenges that are being placed right now because of poor recycling methods. Now I'll talk about the implementation of our system and how it's going to recognize materials that are being put into the bin. Because if it's a one-stop for all, then there should be a way to sort these waste items. So recognizing material from just simple color images is a very challenging problem even today. It's an image recognition problem that is still present today. And now technology is advancing, and we have obviously neural networks which provide a very, very, very almost near perfect accurate recognition for images and objects. It's still under development. It's still a topic that's under huge debate and development. But nevertheless, A lot of recent studies have actually shown very good results and very positive results, and this holds very bright results for the future in terms of deep learning and neural networks. And we even found a paper, which we will be linking in our references section, where the authors review most of the methods in modern machine learning, and they have found pretty positive results in terms of object and image recognition. So what would the components of such a waste bin look like? Well, obviously, since it has to be computerized, there will be a small microcomputer or a small scale computer, which could be a Raspberry Pi microcontroller. And obviously that is just Raspberry Pi is just a small mini computer. It's going to use computation, and it's generally the central processing unit or the main unit of our waste bin. And we obviously evaluated the cost of it, and the cost of such a microcomputer would just be around 300 dirhams, which makes it a viable option to put in such a waste bin. The next thing would be LEDs, which are also very, very inexpensive. These would obviously be used to light up image shots if we are using visual cameras, which are going to be placed inside the bin, right? And I'll talk about these cameras a little bit. The next thing is a motor. So small set of motors that will be used to place items in different placeholders for different size of waste. So one placeholder will be for metal waste, let's say, and there needs to be a motor that transports it there. And these also range from about 10 to 50 dirhams. And the last thing, which I think is the most important part of our such a waste bin, would be the infrared sensors or cameras. So we can set up visual cameras right inside these bins to and that is going to basically take pictures and have us use a neural network to basically identify what kind of an object it is. Is it a metal object? Is it a plastic object? And it'll segregate it based on that. And these visual cameras, infrared sensors also help us aid on finding out what kind of material it can be. And we can also use other sort of sensors and other components to collect more data, and that helps us, that aids us in basically finding out what material it is and gives us with absolute accuracy what placeholder that this certain material should go into. And the cost of such a thing is also very inexpensive, ranging from about 28 dirhams for a small camera module with decent enough megapixels and decent enough clarity. And infrared sensors, well, they range from 200 to 400. So how do we bring it all together? We told you the components. How do we bring it all together? Well, the simple cost-effective system of a small LED light inside the bin and a small camera with a microcontroller running an image recognition model, a neural network model. And this powers a simple motor that can be used inside standard waste bins instead of specialized recycling bins. And this helps us to basically have a one-stop shop to just throw everything, and instead of having multiple bins and specialized hardware to implement a solution. So as you can see, the parts are very inexpensive in terms of our solution.